The first thing is to read the question. Right now, that sounds really simple, doesn't it? But it absolutely isn't. I'm sure you've been told before you did your GCSE, the teacher will have said, read the question, make sure you answer the question. But nobody ever says how you should read the question to make sure that you've read it properly, because you've been learning for years to skim read, and you've got to learn to not do that in your A-level physics. The questions in A-level physics papers are very information dense. They got loads of information in. There's nothing in there that you don't need, pretty much ever, which means that you've got to make sure that you read every question, every word, and sometimes a single letter can make a difference. So this is reading the question is a really, really important skill. Okay, so we're going to read this question, and I want you to point out what are the really important things. Okay, so the mass of a toy train is 200 grams. 0.6 joules of work is done on it by a child's push. So they're doing force through a distance. That's work. They're putting in 0.6 joules of energy. What is the speed of the train immediately after the push if it is initially stationary? Okay, so you're going up. How do I do that? Okay, so we've got some important things. Can anybody pop into the chat what they think the important things are that you should notice in this question to start with? Oh, I've got a response straight away. Okay, so we've got, do you use energy as a half mv squared? Yes, you do. Yes, you do. So you spotted that, but that's not in the question, is it? Okay, the work done formula, again, you spotted that. Also not in the question. And Ria's put the units. Well, yes, the units are really, really important. So we've got 0.6 joules of work, which means that you can tell that work is energy because joules is energy. And we've got 200 grams is the mass. I don't just telling you, I've just pointed out the numbers. And those are the really important things, okay? Sometimes then there's a number that's hiding that doesn't look like a number. And in this question, the number that is hiding that doesn't look like a number is the words initially stationary. Because initially stationary means a speed of 0. Yeah, they are just 0. Yeah, absolutely, they're 0, but they're important, right? And if you don't notice those words and don't really, what's the word? Internalize what they mean, you might miss that actually all of the energy has turned into kinetic energy. So it doesn't matter that we're using the work done formula, because force times distance. We haven't got any information about the force. We haven't got any information about the distance, but we do know how much work was done. So that work done is going to turn into all of it into kinetic energy. And we know that because it was initially stationary. Okay, if it was already moving, then it would have been additional kinetic energy, and we wouldn't have any way of finding out what our final velocity was. So that initially stationary statement, really important. Okay, so you've got to read the question carefully. And we already know, because Ryan told us, that we're going to be using the kinetic energy equation, the GCSE equation. Kinetic energy is a half mv squared. Okay, so next thing. So now we have to note down what you're going to calculate and what you're given. Right, you've got to calculate V. You're given W, work. It's often called W at A level, not to be confused with weight, and everything has more than one meaning, every letter, every symbol. Okay, so you have to calculate V, and you're given W and M. Okay, so we've got, oops, let's pop it in there. So we've got V. That's it's really horrible to read. let's try with white and make it a little bit thicker, shall we? Okay, so V, that's what we're going to get, but we're going to use the energy, or the work is a half mv squared, aren't we? Okay, that's the equation we're going to be using. Okay, so we've noted down what we've been given, what we've got to calculate, and what we've been given, and we've been given those two. W, remember, the work done was 0.6 joules, that's E, and the mass, well, it's 200 grams, but at A level, in fact at GCSE, the standard unit, the SI unit for mass, isn't grams, it's kilograms. So it's 200 grams, and I'm going to say times 10 to the minus 3, because there are 1,000 grams in a kilogram. So if you do 200 times 10 to the minus 3, it's 0.2 kilograms. Okay, so that's our mass. So those are the things that we know, and that's the equation we're going to be ending up using to do it. Right, now let's get rid of all this in the middle so that when I go on to the next page, there we go. Right, so then it says, think what concepts are involved. This is the hard bit. Ryan's already done it for us. Energy is transferred as work done. Conservation of energy means that work done must equal kinetic energy gained. So the velocity is related to kinetic energy, which Ryan already did. He did it in his head because he's brilliant. Okay, next one. So you get work done is energy transferred as kinetic energy. It's half mv squared. Okay, and yeah, 130 tons, that diesel engine. Okay, right. Then it says, oh, I got a message. JS. Oh, is it root 6? Oh, okay. You're way ahead of me. You're way ahead of me. Okay. Okay. So the next thing is, wait, be what's the word? Patient, Ryan. So the next thing is combine equations and rearrange to solve for the required quantity. So we've got our energy is a half mv squared, and we're going to rearrange. So we've got v squared is 2w over m, and v is root of 2w over m. Right, now what I want you to do is, and this book, which you've all got, this daily workout book, which I hope you're still using, and if you haven't been using it, please catch up. This book will help you to rearrange equations and practice standard form and using SI units and doing trig and all those things, all practicing from GCSE initially. Anyway, so you're going to rearrange the equation. This is how loads and loads of A-level physics questions go. And then you're going to substitute your values in the correct SI units. So you're absolutely right, Ria. You needed to notice the unit. So we've got the work done in joules, which it was. The mass needs to be in kilograms, so it's 200 times 10 to the minus 3. And let's put that back at the top. Sorry, my toolbar is in the way. And then we've got 2 times 0.6 over 200 times 10 to the minus 3. And you're absolutely right, Ryan. It's root 6, which is that 2.5. Okay? So perfect. Okay? So then you think you're finished. Well, you sort of have, but one of the things that I want you to do, I want you to check the units of your answer and make sure that it comes to meters per second. This is one way of checking. Now, you don't always have time, and I'm sure with a simple question like this, it wouldn't be that big of a deal. But this is a really good way of checking that you can leave it in root form, or you can transfer it into decimal. If you are going to use it in a subsequent thing, you might find it helpful to leave it in root form, because you haven't got to press the buttons to enter it and stuff. It's nearly always a good idea to give your answer in decimal form in physics papers, partly because there's always at least one question on every paper where they check that you've got the correct number of significant figures. And if you use surds or factors of pi, they can't check that. So your final answer should be quoted in the little space that they leave you on the question paper to the correct number of significant figures. So you would have to eventually turn your root 6 into decimals. Okay. But yeah, leaving it as root 6, especially if you're going to go on to use it in some subsequent equation, and nearly every A-level physics question in the entire history of the world has got more than one equation in it, then yeah, you might want to leave it as root 6. Very good question though. Okay, we're going to move on because I'm conscious of the time. And then the next thing you got to do is to check that you've got the correct number of significant figures, which is what I'm saying, and you should always use the same number as in the question. Can you see here? There's 2, and here, well, it might be 2, it might be 3, it might only be 1. But I would do 2 in this case. If you routinely give your answer to 3, you're very unlikely to get penalised. Unless there's a question where it says, and give it to the correct number of significant figures, in which case you then have to work it out from the numbers in the question. But routinely give it to 3, and then you won't go wrong probably most of the time. Okay, and then finally, you have to check that the answer is reasonable. Okay, now is 2.5 or 2.4 meters per second reasonable for a child's toy train? So 2.5 meters a second is quite quick, but I want you to imagine how long a meter is, you know, one of those meter rules, and put 2.5 of those. Could you get a child's toy to go from one end to 2.5 meters away in about a second? And the answer is yeah, you could. Yeah, it seems reasonable. Yeah. If it was 0.000, you probably got something wrong. And if it's 300, probably got something wrong. Can you see that checking that your answer is reasonable is actually a really important step? And one of the things that you need to be aware of is the typical values for things. So and it would be a good idea if you start right now noticing the sizes of the values in the question and in your answers, because it's the only way. If you know typical values for things, then you can go, oh well, actually that speed's over the speed of light. I've made a mistake.